I'm Jim Nasby. I'm the lead database architect for Enova Financial. Enova Financial launched in 2005. We originally launched on MySQL. About not even a year after we launched, we ended up switching to Postgres. As a company, we sell financial services to people that are traditionally underserved. So largely people that don't have a very good credit rating. Probably our biggest product line is payday lending, but we do some other stuff as well. We operate in the US, Great Britain, Australia, Canada, and last year we did $1 billion worth of loans. We're currently running on version 8.3. We're hoping to migrate up to 8.4 within the next couple months. When I joined the company in 2007, we were running 8.1, so we've gone 8.1, 8.2, 8.3. I don't know if the company originally started on 8.1 or if they were on an earlier version. I'm pretty sure that they were on 8.1 from the get-go. When the company was founded, we're a Rails shop, and the default choice for Rails at the time was MySQL, and of course you've got just a lot of people run MySQL because a lot of people run MySQL. So that's what we started off on, and there were some problems that we had running with MySQL. We had some scalability problems, but the biggest issue that we had is that MySQL makes it easy to accidentally damage your data. You can do things like if you try and put a $1,200 loan, but the field is only set up for 3-digit amounts, then you end up with a $200 loan, and customers really don't like it when that happens. So we had a lot of problems along those lines. Back when the switch was made, which was 2006, I don't remember if the strict mode that MySQL introduced existed back then. If it did, it would have probably been pretty new. But because of those two reasons, the decision was made to switch to Postgres. When it became obvious that the company needed to switch from MySQL to some other database technology, of course, that's a non-trivial effort. So a number of different databases were considered. MS SQL at that point did not talk well with Rails. DB2 was looked at, and it was deemed to be a bit expensive. Of course, Oracle was looked at, and that was really expensive. In fact, in talking to our CIO, the decision that they distinctly made was that to get running on Oracle would have cost about $100,000, and that's someone's salary. So the company made the decision that they would rather hire somebody who will be with the company and can serve, in an ongoing role, rather than take that money and send it to Oracle. So given that the commercial databases that you would immediately think about, none of them really seemed to be a good fit, Postgres then became the obvious choice. So the initial problems that Postgres solved were scalability and data quality. In our environment, we've been able to meet our increasing demand by simply vertical scaling. So we just buy larger and larger and larger hardware. Postgres, at least at the time, did a much better job of being able to scale in that fashion. So we actually just did a migration of part of our schema, and as part of that I ran a parallel migration process, and it was able to scale up to 8 CPUs very, very well. It, of course, was not linear, but it was something like 85–90% of theoretical maximum. So that's something that, MySQL just was not doing very well. The other things that we've been able to do with Postgres that are pretty unique to Postgres is we're using table inheritance. Most people that use table inheritance in Postgres, they're using it for doing table partitioning, but the feature actually predates table partitioning support in Postgres. It's a general inheritance type of paradigm that you see in different programming languages. In Postgres, you can use that in a table level. So the storage is very efficient. You've got a lot of flexibility in how you can use that data. So that's something that we've started making use of. In a more general sense, last year we did $1 billion worth of loans. In our U.S. database, downtime during the day cost us on the order of $100,000 an hour, and all of those systems run on Postgres. I mean, quite simply, it's the lifeblood of our company. Plans for the future regarding Postgres, of course, there's always upgrades. Typically, my experience both at Enova and in previous roles is that upgrading a major version of Postgres will typically get you about a 20–30% performance improvement. And that has carried out. We've seen the same type of improvement going from 8.1 to 8.2, 8.2 to 8.3. I would expect to see something similar when we make it onto 8.4. So for us, with the benefits that Postgres keeps adding to the databases, a lot of companies, they view upgrading databases as a real chore and a nightmare and a challenge, and we actually look forward to it because of the value that's being added with every additional iteration of Postgres as a database. Other stuff that we're doing regarding Postgres is we're actually contributing back to the community. A feature that's coming out in Postgres 9 is hot standby support, so that you can set up a replicated, you can set up a database using point-in-time recovery, and previously you could have it up and running and keeping up to date, but you couldn't do anything with it. Well, now you can actually query against this database. It gives Postgres another form of replication. So we partnered with Second Quadrant to actually fund the feasibility study for that. We're also doing work right now to take LoanDist, which is another replication solution that we're already using, and we're going to make that multi-master. So one of the very nice things about the Postgres community and the various companies that do Postgres work is that when we have a need that can be well laid out and well defined, it's very easy for us to turn to one of these companies and say, hey, here's what we need, let's come to an agreement on an amount, and it gets done, and it's generally pretty easy to add new functions and new features to either the database itself or to other existing support products. That's something that, of course, unless you're a really top-level customer of a commercial database, you're not going to have that kind of control. And even if you can influence a commercial database vendor to add some new kind of feature, it's typically going to take years before you'll actually see that. Whereas with Postgres, the community has done a really good job of sticking to a yearly release cycle. So depending on when you start working on something, it is usually available within a year or two.